assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right, so if we're looking at germanium and we have a band gap of 0.72 eV, that's the energy difference between the top of the valence band and the bottom of the conduction band. What's the range of wavelengths that a photon can have in order to excite an electron from the valence band up to the conduction band? Well, basically, the photon has to have equal or greater energy to impart some energy to the electron and give it a boost into the conduction band, because it can always there could be a readmittance of the photon of the energy difference, right? If it's greater than 0.72 eV, it can give 0.72 eV to the electron, and then another photon of the difference in energy can come out. So as long as it has that amount of energy or greater, it can excite the electron. So in terms of wavelength, it has a certain wavelength cap, and then the wavelength goes lower because remember, energy is inversely proportionate to wavelength. So the wavelength given by speed of light over frequency, um, we can multiply both by h, because we'll get hc over the energy, right? Because hf is going to give us energy. So hc over energy is wavelength. You could have just gotten that from a well-known relationship anyway. Let's just figure it out, right? This is like the maximum, or I said the minimum amount of energy needed. So basically, we're saying that the wavelength has to be less than or equal to this, right? If we plug in H and C and then plug in the energy gap of 0.72 eV, we will get that it has to be less than or equal to 1.7 times 10 to the minus 6 meters. Lambda must be less than or equal to 1.7 micrometers.